But you?
Good. So what do we got going tonight?
Just more review. I'll verbalize it for you.
Okay.
Let's see. Okay, so the first problem wants to have the polynomial factored completely.
Okay.
And it's g of x is equal to x to the fourth minus 256.
If I said to you, what is this? How does that factor?
It would factor a plus b and then a minus b.
Okay. So what we have up here is the same as this. Correct?
Yeah.
So how does this factor?
So that would be x squared plus 16 and x squared minus 16.
There you go. In other words, this is not technically difference of perfect squares, but it actually is, because it's x squared and 16 squared. So sometimes you have to look beyond what you just see and see if you can treat it as something that you know how to do. In other words, normally we don't know how to factor the difference of perfect fourths.
Okay.
Okay.
So the next question is g of x is equal to 4x to the 9th minus 49, and it wants it rewritten in standard form, tell the degree, the leading coefficient, and the end behavior.
That's the whole function, 4x to the 9th minus 49?
Yeah.
What's it want?
What? Oh, it wants to have it rewritten in standard form and to tell the degree.
It's in standard form.
Okay, and then to tell the degree, leading coefficient, and the end behavior.
What's the degree?
9.
What's the leading coefficient?
9.
4.
Oh, yeah.
Coefficient is the number in front of the variable. Always. It's kind of the definition of it. And then the end behavior. Okay, so end behavior, there's two end behaviors. One as x goes to negative infinity, and one as x goes to positive infinity.
Okay.
This is left-hand end behavior. This is right-hand end behavior. Now, the easiest way to do these, for me, is to treat negative infinity like it's a number. Just plug it in. What is negative infinity to the 9th power?
Negative infinity.
That's the left-hand end behavior. In other words, as x goes to negative infinity, g of x goes also to negative infinity.
Okay.
Right-hand end behavior, you plug positive infinity in. What's positive infinity to the 9th power?
Positive infinity.
So that's the difference. The left-hand end behavior is negative infinity. The right hand is positive.
Okay.
Now, technically, infinity is not a number. But what you need to know is when you take a negative infinity and you square it, it becomes positive infinity. If you take it to an odd power, it stays negative. If I take it to the fourth power, it becomes positive infinity. So it's basically, if you're taking it to an odd power, it's going to stay negative infinity. If you take it to an even power, it's going to turn into a positive infinity.
Okay.
Okay. Now, this problem looked kind of interesting when I first looked at it, because it looks almost like difference of perfect squares. And I suppose it kind of is. What's the square root of that? Well, how about 2x to the 9 halves plus the square root of that? That should be a true statement.
Okay.
Not a typical way to factor something by giving it a fractional exponent. But you also, it's not very typical having ninth degree polynomials. What else you got, Jonathan?
So then the next problem wants the same as the previous problem, and it's x cubed minus 4x to the 10th minus x plus 28.
Did I write that correct?
Yep.
What's the degree?
The degree is 10.
What's the leading coefficient?
-4.
Okay. Now, in terms of end behavior, there's only one term that matters. That's that one.
Okay.
The leading one only. Nothing else matters. I could have plus 1,000,000 x to the 9th. Wouldn't affect anything. When you're talking end behavior, it is strictly that largest exponent. Now, as x goes to negative infinity, what does g of x go to?
Positive infinity.
Look again. I'm going to plug negative infinity in for x. So this part goes to positive infinity, but I'm still multiplying it by a negative sign.
Okay. Oh, so it's just negative infinity always.
In other words, this negative sign here is not being taken to the 10th power. The 10th power only applies to that x. Doesn't even apply to the 4. So it stays negative infinity. Now, what happens when x goes to positive infinity? What does g of x do?
It stays negative infinity.
Right.
Yeah.
What that means graphically is that it starts from down there. You might have 9 squiggles in there, but it ends up going down there also. In other words, that's what that means, is it means it starts from down there, and that means it ends down there also. And the reason I say it would have 9 squiggles is because it's a 10th degree polynomial, and you almost always have one less extrema than you have degree. If you'll notice x squared, that has one wiggle only. In other words, one extrema right there. X cubed could look like this, where it has one extrema there and another one there, but it's only going to have two.
Okay.
Okay. What else?
Let's see.
Some of this stuff you may or may not get this year. I don't know. You're getting an awful lot of pre-calc here. And that's pre-calc stuff. Stuff that I just told you that you may not have been taught in class yet.
The next one just wants it to be the function to be simplified to standard form.
Okay.
That's 2x is equal to 3x minus 4, and that's all in like a closed parentheses, and then 2 to the third, or cubed.
Like that?
Let's see. Double check. No 2. No 2.
Oh, the whole thing is to the third power?
Yeah.
Okay. And what do they want?
For it to be
Just
simplified into standard form.
Okay. Standard form being ax to whatever power, in this case 3, plus bx squared plus cx plus d. In other words, that's what standard form basically is. So what do we have to do here?
Distribute the 3. The 3.
It's not really called distribute. It's not multiplying. In other words, this is technically equal to the following. So what you have to do is multiply these three things.
Okay.
And the way you do it is you multiply two of them, you take the result, and you multiply it by the third one.
Okay.
So multiply the first two. There actually is a binomial theorem that, depending on how big the exponent is, could be an easier way to do it. But when your exponent is 3, probably the easiest way to do it is just to multiply it out. Okay. But make that exponent 13, and then I don't want to spend an hour multiplying it out, so I'll go to the binomial theorem, and it shows me exactly what the answer will look like.
Okay.
But if it's only 3, your quickest way is to just go ahead and multiply it. So multiply that by that, for starters.
So that would be 9x squared plus 16.
There's a middle term. What's the O and the I of FOIL going to add to?
Oh, that would be minus 12x.
So there's two of them. There's that minus 12x and there's that minus 12x. So it's minus 24x. I didn't mean the O and the I meant the I and the L is what produces, or not, no, that is the O and the I, the inside and the outside, yeah. And then the L is 16. So now we have that times that. And now FOIL doesn't work, but ET does. So go. I'll start writing.
Okay, so that would be 27x cubed minus 72x squared.
Okay, let me suggest something. When you're doing ET, always follow the same exact pattern. Don't jump around. What's going to happen is if you're multiplying like a trinomial by a trinomial and you jump around, you're going to forget one of the terms. So by following the same method, what I mean is you start from the left and you do all of those. So you do that one and then you do that one. You don't do the first one and then do the second one and then the third one. I mean, you could. It'll give you the same answer. But the secret to doing these things is to do it the same way every time.
Okay.
Okay. Now, perhaps you were doing it the same way as you always do it. I don't know. To me, I like starting from the left and finishing all of the multiplication of that term on the left right there. Let's finish that.
Okay, so then that would be minus 36x squared.
Okay, now go to the second term and do all those two.
Okay, then minus 72x squared. Plus 96x.
And now do the 16.
Minus 48x. No, plus 48x. Minus, let's see, that would be 64.
Okay, simplify.
So then that would be negative.
Start with the biggest term first on the left.
So it would just be 27x cubed.
There's always only one each of the term on the left and the term on the right. In other words, there's only going to be one x cubed term and there's only going to be one number. But everything in the middle has got to be combined, not into one term, but in other words, you can combine those two and you can combine those two. You're never going to combine, in other words, you don't need to look for other x cubes, is what I'm trying to say.
Okay. So then minus 108x squared plus 144x. Oh yeah, minus 64.
And that's in standard format. And
Okay.
I don't see anything else we could do with that. Okay?
Okay. So
It'd be a tough problem. If they gave you the polynomial and they said factor it, getting back to that would not be easy.
So the next one wants to do the same as the previous problem.
Okay?
And it's h of x is equal to 2x plus 1, and that's in parentheses, and then another parentheses, x minus 3, and then another parentheses, x plus 4.
Okay, we have 10 minutes. You want to do this one or do you want to go to another one?
I think I'll try this one, yeah.
Okay, go ahead.
Okay, so I'm going to start with the farthest one and multiply it across. So that would be 2x squared. And then what I want to multiply...
Same
like
pattern, same method. Start from the left and finish all of it.
Okay, so then plus 8x.
Hold on. By finishing all of it, I mean finish multiplying that times that. You're not looking at this third term yet. You're going to wait until you multiply these first two together. Then you're going to multiply that trinomial by this binomial.
Okay.
So when I meant finish it, I meant do that next.
Okay. And so then minus 6x plus x minus 3.
Okay. Now, that needs to be simplified.
So it would be 2x squared minus 5x minus 3.
And now that's what you're going to multiply times x plus 4.
Okay. So then that would be 2x cubed plus 8x squared minus 5x squared minus 3x.
Oops. Forgot to finish that one. In other words, you did the minus 5x times the x. Now you got to do it times the plus 4.
Oh, yeah. And then minus 20x minus 12. Oh, wait, minus 3x.
See, that's why I think it's so important to follow an exact pattern and do it that way every single time.
Okay.
Don't jump around. I see a lot of people where they'll do this times that, and then they'll do that times that, and then they'll go back and do this times that, and then they'll try this times that. By the time you're done, you're not sure you've done everything. So just start from the left, multiply both terms by that, and then both terms by that, and then both terms by that.
Okay.
And then always in the simplification, you're combining those terms only. So what's the rest of it?
So then that's plus 3x squared minus 23x minus 12.
Yeah. Okay, what else?
Okay. Then, let's see, so we finished up all those problems. So this one wants us to factor the polynomial, and it's negative 3x to the fourth plus 6x cubed plus 24 squared, x squared.
And that's it, right?
Yeah.
Okay, the reason I knew that was it was because if we had more terms, we wouldn't be able to do it.
Okay.
Because they haven't taught you how to factor a quartic yet. For that matter, they haven't really taught you how to factor a cubic, except by that one technique of grouping. And that works on so very few cubics. So if I can't factor it, because I haven't been taught, what can I do? Always the very first thing you want to look at is greatest common factor. Can I do a greatest common factor?
Yeah.
What am I going to factor out?
3.
Nope. That'll still leave us with a quartic. In other words, that won't help much. I'll still have minus x to the fourth plus 2x to the third plus 8x squared. I won't be able to do that either.
Okay.
So when you're looking for a greatest common factor, don't forget the variables. Everybody always forgets the variables.
Okay, so...
Factor out an x squared also.
Oh, yeah.
Okay. Now, do I want to factor out a 3x squared, or do I want to factor out a negative 3x squared?
A negative 3x squared.
The reason is because the thing that's going to be left over is going to be a quadratic. You always want your quadratics to have a positive leading coefficient. So what is left over?
So x squared minus 2x minus 8.
Yeah, and see, that's really easy to factor. You try factoring this. It'll drive you nuts. If you're not used to trying to factor where there's a negative coefficient in front of the x squared, it is not any fun. So always get your quadratics in a state that you can go further. Now, we can factor that pretty easily. The quadratic that's in the parentheses, how do you factor that? Do it
Probably
step by step.
So x minus.
Hold on. That's not the best way to do it. You're trying to figure out the first factor all by itself. That's not the way to do it. You're going to do both at once. So the first step is to split up the x squareds into an x times an x. The second step is to figure out both signs. And I know what both signs are because you can't produce a negative 8 unless the signs are different.
Okay.
Notice that I haven't solved either one yet. I'm going to solve them together at the end, after the third or the fourth step. But this is where people go wrong on factoring, is they try to figure out that all on its own first. And it's hard to do. Really hard to do. If you do it this other method, now the third step is what? Factors of 8 that do what?
2.
That subtract to the number 2. Why subtract? Because that's a negative sign. And we're just looking to get that number. We're not looking to get the negative 2 or anything. We're just looking for factors of 8 that subtract the 2. Well, what factors would those be?
Negative 4 and 2.
Well, just 4 and 2.
Okay.
Now take the largest factor, the 4, and put it with the sign of the middle term. Well, the sign of the middle term is negative. That's where the 4's got to go. 2's got to go there. And if you look at it in that way, then you really don't have to pay any attention to these signs. I mean, you do, but you do it in a different way. In other words, you're not really looking for factors of 8 or negative 8. You're looking for factors of 8 that subtract to the number 2.
Okay.
No matter whether that's a minus 2x or a plus 2x. Even if it was a plus 2x, you'd be looking for factors of 8 that subtract to the number 2. It's just that in this case, the bigger factor, 4, would have to go with the plus sign. If it was like that.
Okay.
Now I have it fully factored, incidentally. In other words, that's all they asked you to do, right? Was fully factor it?
Yeah.
Okay. This factor has x equals 0, but it has a multiplicity of 2. This factor is x equals minus 4 with multiplicity of 1. And this factor is x equals 2 with multiplicity of 1. You know what multiplicity is? Have they taught you that yet?
I think I've heard it, but I've never really understood it.
Okay, well, do you see why? In other words, because it's x squared, that's basically x times x. So there's really 2 zeros at 0.
Okay.
There's only 1 0 at negative 4. There's only 1 0 at 2. But at 0 itself, there's actually 2 zeros. And the implications of that are pretty important. If you have an even multiplicity, it does not cross the x-axis. It bounces up. So I know that the multiplicity at -4, that thing's going to go across the x-axis. And I know the multiplicity at 2 is 1, so that thing's going to go across the x-axis.
Okay.
0, it would bounce off. Okay, so that's why multiplicity is important, is it really helps when you go to graph it. Once you have all the zeros and you have each of their multiplicities and you know the end behavior, you can pretty much graph it exactly.
Okay.
Okay. Jonathan, I will let you go, and I'll talk to you next time.
Okay.
All right. Good night. Bye-bye.